Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams PFM, LTAM, and IFM that I offer. I direct the Actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU-actuary. Here's a problem for today. For exam FM on financial mathematics, you are given the following information for a bond portfolio. Bond A has a term of 10 years, has an annual coupon rate paid semi-annually of 0. Its price is 122. Its nominal value is 200. Bond B has a term of 3 years, annual coupon rate paid semi-annually of 4.8%. Its price is 100. Its nominal value is 100. Bond C has a term of 5 years. It pays a floating rate equal to 1-year Treasury bill rate plus 50 basis points and resets annually. Its price is 100. Its nominal value is 100. The floating rate has just been reset based on the 1-year Treasury bill rate of 4%, bond equivalent yield. Calculate the effective duration of the portfolio. Here's the solution. So let's start with Bond A. Bond A is a zero coupon bond maturing in 10 years. Its Macaulay duration is 10 years. We know that. Its effective duration is the Macaulay duration divided by 1 plus I, where I is an appropriate effective annual interest rate. And it's the interest rate for this bond. Because this bond matures at 200 and its current price is 122, the effective annual interest rate for it is IA equal to 200 divided by 122 to the 1/10 minus 1, that's approximately 5.067166%. And its effective duration is 10 divided by 1 plus that interest rate, that's approximately 9.5177213. Bond B is a coupon bond trading at par, and therefore its yield rate is equal to the coupon rate of 2.4 semi-annually, 2.4%. Because its annual rate is 4.8, but we are told that it's nominal annual compounded semi-annually. This is equivalent to the annual effective interest rate of 1.024%, 1 plus 0.024%, plus 2.4%, so 1.024 squared minus 1, and that's approximately 4.8576%. And its Macaulay duration is, well, basically the weighted average time until payment, and the payments come at times 0.5, 1, 1.5, 2, 2.5, and 3. And the payments are 2.4, 2.4, 2.4, 2.4, 2.4, and 102.4 per 100. The price is 100, so we divide everything by 100, and at the top we have each cash flow present value multiplied by the time of payment. And this requires a little bit of calculation, but it comes out to be about 2.82961626. Its duration is Macaulay duration divided by 1 plus the annual effective interest rate, and 1 plus annual effective interest rate is equal to 1 plus IB, so 1.024 squared. And the result of this calculation is 2.69853235. Bond C is based on the Treasury bill bond equivalent yield of 4%. For Treasury bills, bond equivalent yield is defined as the face value minus the price divided by the price times 365 over n, when n is where n is the number of days remaining till Treasury bills maturity. The price of a Treasury bill is the present value of its maturity value based on its effective yield. Since this is an annual bill, n is equal to 365. Therefore, assuming 10,000 face value, 4% bond equivalent yield must be equal to 1,000 minus the price divided by the price. And so that the price times 1.04 is 10,000. And this tells us that the effective annual interest rate on the Treasury bill is 4%. And on bond C, it is 4.50% because this bond's rate is T-bill plus 50 basis points. It produces a cash flow of 4.5 plus 100, the reset value, because the reset means that its value becomes the nominal value when the interest rate resets and the interest rate changes to then current going rate, which in this case is the Treasury bill rate plus 50 basis points. So the effective duration, so its Macaulay duration is 1, because basically it makes a payment 1 year from now, a payment of reset value, which is the full principal return, basically, plus the interest. So the cash flow is at time 1, so Macaulay duration is 1. And its effective duration is 1 divided by 1.045, because that's the yield rate at which we're doing the calculation. So this is 4.5% is. So this is 0.9569378. Note that the total price, so the market value of the entire portfolio, by the way, is 322. We just get this by adding the values of the three. So the effective duration of the entire portfolio is a market value weighted average of the effective durations of the pieces of the portfolio. It's 122 over 322, that's the fraction invested in the first bond, times its effective duration. 100 over 322, the fraction invested in the second bond, times its effective duration, plus 100 over 322, the fraction invested in the third bond, times its Macaulay duration, and this comes out to be 4.74133,234, which is answer A. Please remember this is copyrighted material. The problem itself comes from the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.